Hello, everyone. Thank you for being part of our sprint presentation today. We are the ESDC Team 1 and are working on the Policy Difference Engine. Talking about our team, I would like to introduce Reagan, our talented developer, Cedra, our creative UX designer, and myself as the product manager. Our aim here is to help you understand the problem statement we were given, the value and importance of the work we will be undertaking as part of this sprint and the bigger project we've been assigned. We will give you a technical overview, talk about our UX approach, and lastly, we will showcase our proposed solution and next steps.
Linear solutions will not meet the emerging and exponential needs of society. This is a quote that we found by Pia Andrews, who is a giant in this space. What we think this quote is about is the fact that linear solutions don't typically capture the holistic experience of a user, and they don't always capture outliers. When we model something, we're not always able to capture all of the different situations and considerations that may apply to people. Outliers are essentially people who don't follow a typical trajectory in their life story. Our project tells us that this has happened, where we have overlooked the needs of people who perhaps needed multiple types of funding. In the interest of access, how do we quantify human experience into a model? This whole conversation is basically around balancing the needs of the user with the desire to automate and create better efficiency within government systems. So our presentation essentially covers what we think is a great balance between the two.
Our sprint challenge was to become familiar with the rules as code concept and how a policy difference engine could integrate with existing tools such as OpenFisca. You might ask, what is a policy difference engine? It's a tool for policy, research, and service design. It will help stakeholders such as researchers, analysts, and service designers get a sense of how changes to a particular program might impact government clients, service levels, and operating costs. Why a PDE is important. Policy Difference Engine can increase our government's policy and service agility, enabling them to experiment at a larger scale with less side effects. It helps them forecast the outcome of a change in policy. Last but not least, the Policy Difference Engine helps our government build the much needed capacity to meet the exponential needs of our citizens.
So a significant aspect of this engine is going to be simulating and forecasting changes to existing legislation to better understand the impact of these potential changes. So in order to run these simulations, some degree of automation may be required. So the particular legislation that we might be working with will need to be interpreted and programmed into a computer. Legislation is traditionally not written with this in mind, so there will need to be some conversion. So let's just take a simple example from a New Zealand study that calculates the eligibility for a child disability allowance. Having a serious disability as defined by the Social Security Act from 1964, it needs to be observed that they require constant care and attention, and they need to meet the threshold for months of having the certified disability. And furthermore, they also need to have, they need to be of the age that meets the child age threshold, which in this case is 18. So now that we can express the rule clearly and logically, we are able to code this into a system. So now that it's in there, we can easily check for eligibility and also run simulations on what might happen if we start to change some of these values. So what we've done is we've taken a set of written legislation or rules and turned it into code. This gives us the term rules as code.
For a policy difference engine to work and work the way we just described it, we need to make sure our legislation and policies are human and machine readable, so they are better suited for delivery of digital services. We call this concept rules as code. It is not an automated law, it is not an interpretation or translation engine, and it certainly is not a website.
Okay, so we can sketch out a general flow of what our solution might look like. We start with written legislation. We determine the best candidates to convert into rules as code. We make that conversion. Once we've done this conversion into rules as code, we can simulate what might happen if we change certain parts of it. So with this model in mind, I want to introduce just a few concrete technologies that we're going to explore that might fit in with this approach. First of all, natural language processing, or NLP, which is the field of building systems that can understand and produce human language. Some common applications include spam filters, chatbots, autocomplete, sentiment analysis on product reviews and Twitter, etc. The field has roots in the 60s, but it hasn't come to prominence until recently due to increased availability of data to work with and faster computer processing speeds. Some potential use cases for us could be to help determine if written legislation is suitable for rules as code, and it could also be used for grouping and linking similar pieces of legislation. So there is a case study for the Accessibility for Ontarians with Disabilities Act that had some similar goals. So we are hoping to leverage that knowledge in our system as well. And just a very quick example of an algorithm that is responsible for sorting email into ham or spam. Ham meaning the email is good or not spam. It's been given thousands of examples of emails that have been labeled as being spam or ham. This data set actually comes from Enron. So once it has this pre-trained data, it builds a model based on those examples, and then you can test it with new examples. So for example, you can see if you have the word prescription, that gives it points towards being counted as spam. But if you have the word forwarded, then it's more likely to be ham. So the good parts of this, there are well-established techniques and conventions in the field of NLP and a lot of good open source libraries to work with. The not so good is that much of machine learning relies on having a lot of pre-labeled data that you can use to train models, like that email example. But in the field of government legislation, there is not much of this. So while the ideas of NLP are well established, this particular application, not so much. Legislation can also have a very context-sensitive language, which can make it difficult to generalize into larger rules. So OpenFisca is simply an open source software that allows you to model a rules as code environment. So if we can understand what rules as code is as a concept, OpenFisca is simply an open source platform for that. To the right, you can see an example of rules as code. This is part of the same example we saw earlier, and it's coded in Python. So this can allow us to check out eligibility of benefits, simulate impact of changing legislation. There's been quite a bit of exploration with this from other countries, so we're hoping to build on that as well. One note about this is that it is not a tool for converting written legislation to rules as code. This assumes you're coming in with rules as code to begin with. And this is the catch. The conversion from written legislation to rules as code is anything but trivial. So now that we've looked at these two technologies, we can see how they might map onto our general solution to make it more concrete. We use NLP to scan written legislation and help identify candidates for rules as code and find links between pieces of legislation. Realistically, the conversion itself will still be manual, but NLP may be able to help. We can start with the precedents established by other countries and apply it to the Canadian context. Once we have those encoded in rules as code, we can fire it into the OpenFisca system and run simulations. The goal is that this can be a continuously improving pipeline on existing legislation and also be a driver to encourage new legislation to be more machine friendly.
In our sprint, we spent considerable time in research and discovery, ideation and planning, discussing user experience, and most importantly, examining the available state of technology to ensure that our solution is feasible and aligned with the problem statement. Now I'm going to hand over the presentation to Sidra to discuss the UX aspect of our sprint.
We had 3 days to execute our sprint, which is a pretty short period of time. And realistically, in that period of time, depending on how we prioritize what we wanted to do, we didn't necessarily have time to execute a full round of user testing. We also didn't have time to interview folks because we felt that there wasn't a lot of value during the ideation stage. In our opinion, not having enough information was not an excuse to not start. This brings me to the sources that we did use for our research. We used a wide variety of sources, and our government partners were great about providing us with quite a few slide decks and documents. We also looked at proto-personas, which I'll go into in the next slide. We did a user experience ideation activity. We also attended some very interesting OpenFisca and NLP 101 workshops that were run by Reagan. And we also looked at documentation pretty extensively in order to better understand the problem. The idea behind a proto-persona is that sometimes when you don't have all the information, but you have some of the information, it is possible to extrapolate. Proto-personas are based on the assumptions of the stakeholders and then further checked against actual data. They're a collection of heuristics, market research, and intuition that presents an opportunity to articulate the target audience needs and behaviors. We'd like to thank the Service Innovation Lab on GitHub for providing us with these three roles that we felt were fairly applicable to the categories of stakeholders in this project specifically. So we did a user experience ideation exercise, and the overall question was, if something takes 50 steps, is it really an improvement if you just end up making the process digital? In order to stay away from the concept of digital for digital's sake, we really wanted to think about how to extract the intrinsic and fundamental product value from the solution that we're going to build. So as a team, we went blue sky and we talked about products that take input in a specific way and transform into machine readable code in order to execute a specific function. These products include apps many of us use every day, like Spotify, Uber Eats, and Strava. So it's pretty interesting to create some comparisons. We also wanted to think about how do those products do this really well and where do they miss the mark when it came to thinking about our own. This brings me to the concept of cascading needs. So the same policy, the same rules, the same functions, the same problems can cascade down a list of personas and serve very different functions for each one. So for example, if I'm the rule writer, I want to draft legislation and legal requirements, and my primary interest is in preserving the integrity of legal language and the spirit within which the law was drafted. But if I'm a rule user, which would include our business users, agencies, divisions, they would want to integrate these rules in a way that lets them model them and see their impact on things like eligibility and understand how it impacts folks. And then finally, we've got impacted people who are trying to figure out how much they're entitled to in an intuitive way and receive that entitlement in a timely and accurate manner. As evident by this diagram, there are a lot of things at stake, but that also means that there are a lot of opportunities. So what are the stakes? Well, we need to start speaking the same language. So there's a few things that we need to consider. Expecting specialists to generalize is a really big ask. We need to be considerate of the domain within which people have expertise. Corner of the desk work is a big consideration, and that just means that it's probably against our best interest to introduce any significant knowledge translation. It's a lot of work, let's be honest. And frankly, if we continue with business as usual, as per the project charter, we open ourselves up to more lawsuits, as well as missing out on the needs of folks that need to access these services the most. So with these things in mind, we really wanted to think about what is that sweet spot? The sweet spot is about an opportunity to create something to improve the flow, whether that's the flow of information or the flow of services. So as we've seen, there are a lot of opportunities to intervene, but one place that we found a gap, a significant gap, is that between the rule writers and the rule users. So we decided to ideate and we decided to come up with our problem. Our problem is, how might we make it easier for rule users to transform legislation into real and actionable insights? So we designed Project Babel. You search legislation docs, you select a legislation that makes sense to you, you highlight or you select the chapter that you want to start editing, you highlight sections of that are identified by NLP as to which are the best candidates. And then when you click certain terms, you're able to start building the relationships between them. So you can do things like add exceptions and eligibility status, and then you can also view the rules as code to improve understanding across different domains.
During our sprint, we identified two ethical considerations. One is preserving the spirit of the legislation. We understand that there are parts of laws that might not be transferable to a coding language, and we need to be mindful of this. The second, reducing humans to numbers may result in loss of important details. What is the key takeaway of our presentation? In our sprint, we were challenged to ideate on how a policy difference engine could integrate with existing tools such as OpenFisca. Our research and discovery demonstrated that OpenFisca can only work with rules as code. Therefore, our very first step for such integration, as just was shown by Sidra, is to find a way to transform the existing legislations into machine-readable language. This in itself is going to be a time-consuming and complex undertaking. What are our next steps? Through conversation with our government partners, and as we reviewed the documents provided to us, we've come to recognize and appreciate that Some work has already been done, though in isolation and independent of each other. To move forward, it is of value to connect people and their contribution to the bigger picture of our project and ensure that the available knowledge and expertise are leveraged effectively. Here's a list of our resources and further reading, and we want to thank you for taking the time to listen to our presentation. We are here if you have any questions.